Hello and welcome. So we're going to be looking at triangle, midsegments, and medians today. So first we need to learn what a midpoint is to build up to midsegments. So a midpoint is, as it sounds, exactly in the middle of a line segment. So C is in the middle between A and B. It is called a midpoint. Now that implies if something is in the middle, that means that AC is congruent to C to B, right? If it's in the middle, it's cutting something into two equal pieces. Okay, so that is what a midpoint guarantees, two congruent segments. So next thing is a mid-segment. As essentially, if you have a triangle where you have a midpoint D and a midpoint E, right? If you were to connect those two midpoints together, you get what is called a, right there, mid-segment. All right, so DE is what we call a mid-segment of triangle ABC. All right, now it's possible for you to connect multiple mid-segments together. So let's say we also had the mid-segment from A to C, right? Let's call that, I don't know, point F or something. You could additionally create a mid-segment from F to E, and you could also connect D and F and create a mid-segment. So you can have up to 3 mid-segments and create a little triforce symbol there in a triangle. Okay. Now, with mid-segments, we get something fancy called the triangle mid-segment theorem. And that essentially says that a mid-segment of a triangle is parallel to one of the sides in a triangle. And the length of that midsegment is half of the length of the side it's parallel to. So, for example, we said that DE was a midsegment. Just using your eyes, you can tell that it's parallel to AC, and it's guaranteed. It's guaranteed to be parallel to AC by that triangle midsegment theorem. Now, in addition, is we can tell that DE, this is going to be half of that. Right? It's half of the whole. So you can double the small to get the whole, or you can half the whole to get the small. So we get this double half relationship from midsegments to their I hesitate to say corresponding, but to the side they're parallel to in triangles. Okay, so let's practice this a bit. So it says solve for x and or the requested length. So GE is what we need to find right here. Now you'll notice that that is the side parallel to our midsegment from L to M, and we can tell that L and M are midpoints because we are seeing that they're cutting that triangle, right, into equal parts, right? So if my midsegment is 8, that means if I can double the small, I get the big. Okay, I know it's not going to be half because that wouldn't make any sense. Half of this segment is clearly not the same size as that whole thing. Okay, so do keep that in mind. We're doubling it, small, double it to get the big. If it was the bigger side, you would half it, get the small. So GE, 16. All right, next thing, same idea. We can tell L and K are midpoints, which means midsegment is LK, which is what we're trying to find in this case. All right, now the side it's parallel to, QS, is 12. Now, if that is the bigger length, we need to half it to get our midsegment. So half of 12 is 6, right? Which means LK is a length of 6. Now, in addition, it asks us to find x. Now, x, you'll notice, are angles, right? We see an angle in our triangle, right? This usually freaks students out. They're like, I don't know how to do this. Don't freak out. You know how to do this. What do all angles in a triangle add up to? 180, right? That means that 3x plus x plus 6 plus, what does this box mean? 90 degrees, right? And you know they all add up to 180. That's true for every triangle. There you go. So 3x plus x, 4x, 6, and 90, 96. And then solve for x. So we're going to subtract 96. Move that over. We get 4x equals 84, I believe. Okay, and then we just finish it out, divide by 4, undo that multiplication with division, and we get x equaling the illustrious number of 21, it looks like. There we go, right? And now just double check your answer, right? If I plug 21 in, 3 times 21 is 63, positive number. 21 plus 6 is 27, positive number. Right? Remember, when you plug something back into geometric diagrams, you don't want angles or lengths of 0, and you don't want negative lengths or negative angles either. They wouldn't make sense in our diagram. All right, so that is example B. C, we're now working with longer expressions, but that's totally fine, right? We see that 2x minus 5 is our m to n. mn is a mid-segment, we can see from our notation given to us. Now, k to I, we're seeing is 3x minus 2, and that is the side parallel to our mid-segment, which means we have that double half relationship. I like doubling over halving. Fractions are a little harder to work with, or at least easier to get confused with. So I'd say, okay, well, I know that if I double my small, right? If I double my small, I'm going to get the big, right? So that means that if I double the length of my small, it equals the larger length. Really similar. It's exactly what we just did on A, right? But instead of just little numbers, we're working with an expression now. So times 2 over, so 4x minus 10 equals 3x minus 2. Combine your x's. I'm going to subtract 3x, keep my x's positive. 4 minus 3 is 1x. Also going to add 10 at the same step, save ourselves a little time. Negative 2 plus 10 is 8, so x equals 8. And then same thing, just plug it in to make sure there's no issue. 2 times 8 is 16, minus 5 is 11, right? 3 times 8, 24, minus 2, 22. And you can see that double half relationship working, right? If we double 11, we get 22, or if you half 22, we get 11. So 8, valid solution, you're good to go. Now D is exactly like what C was doing. Like literally the exact same process, right? You have your mid-segment. We can see it's mid-segment from notation there, right? So we have mid-segment, the line or the leg in the triangle that it's parallel to, we're told is x plus 23. So I would set that up the same way, where I would say I'm going to double my 2x plus 25 to get my longer segment x plus 23. Right? Because I know that if I double the small, we get the big. Okay, so distribute that 2 in. 4x plus 50 equals x plus 23. I'm going to move the x over. And in the same step, also move that 50. Okay, so on the left, we're left with 3x. On the right, we have 23 minus 50, so negative 27. Divide 3 both sides, and we get x equals negative 9. Now double check, right? Negative numbers, you might be freaking out. It's like, it's a negative, can't have negatives. Can't have negative links. Double check to make sure it works. So we plug it in, we get 2 times negative 9, that's negative 18, right? Plus 25 gives us the positive value of 7. That's actually okay, right? Now in the other one, we get negative 9 plus 23. And when we get that, let's see, that's what, 14? That's a positive number, meaning, yes, you have a negative solution, and that's not a problem, right? Because we had positive lengths when we plugged it back in. So there you go, that is mid-segments. All right, so now let's talk about medians. So a median, so we have our midpoints, D, E, and F. Okay, so a median is a line that starts at the vertex to the midpoint of the opposite side. So vertex refers to A, B, and C in this triangle. So if I were to take one of those vertices, let's do A, and I connect it all the way to the midpoint across my triangle, then this line gets to be called, the line we just created, well, a little easier to see there, that is what a median is. Okay, so another median would be from B to its midpoint on the opposite side, F, or D to its midpoint on the opposite side, D to the vertex, C. Okay, so you can have up to 3 medians in your triangle, 1 from each vertex to midpoint. Okay, now you'll notice that when we drew all of those medians, they intersected right there. That also has a special term. That point alone can be called what is known as a centroid. in the triangle. I'm going to label this M. Okay, so we have a centroid, and that is when all three medians intersect. Okay, now there's actually a really cool relationship between your midpoints, the centroid, and the vertex of the triangle. And essentially what that relationship is that the length from centroid to midpoint is half of the length from the centroid to the vertex. So that means if this was a length of x, this would be double that length. Okay, which means the whole thing together is 3 times the length of that centroid to midpoint. Okay, so if you have the entire length, you can slice it up into thirds, right? That would be a third. So 1/3, 2/3, 3/3 kind of a thing. But you'll always have 1/3 here and 2/3 there. And that will always, 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 always be true when you have medians with the centroid. All right, so let's use that, find some information down below. So A, it says find the length from S to W. So S to W right here, right? And W to H, let's not use blue there, okay? W to H, if S to H, which is that whole thing there, is 7.5. So if I know the whole thing is 7.5, then we can pretty much do what we were talking about here, where I can break this down into thirds. Where I'd say, okay, 7.5, slice it up into 3 equal pieces. How big is each piece? 2.5. That means that our first third from W to H is 2.5. The next third is 2.5, and the next third is 2.5. So the whole thing is 7.5. Right, 2.5 is our W to H, right? And then double that, in other words, count the other 2/3, and you get 5 exactly for S to W. There you go. All right, so let's do that again. This one we're told W to G is 24. So W to G is right here. That is 24. And then it asks us to find R to G, which is the whole thing, right? That's R to G. And then it also wants us to find R to W, which is just the remaining segment there. Okay. Let me use a different color for that. Okay, so R to W. So I'd say, okay, well, we have that double half relationship, right? If I know that this is half of this one, right? If I double times by 2, we double it, and we get 48. And that is your length from R to W. Because you also know if that's 1/3, then this section is 24, and that section, right? Those two sections are both 24, total of 48. All right, so RW equals 48. Now, if I want to know the whole thing, R to G, same process. Now I just know it's 24 and 48 combined, which gives us a total of 72. Done. Okay, so just using that relationship there. Now, C and D are actual algebraic expressions, so let's start with C and go to D next. So it says find TW if TI equals 7x plus 3 and WI equals 5x minus 3. So let's do WI first. WI is our centroid to midpoint. Okay, and then we also see that we have 7x plus 3 is T to I, which is the whole distance there. And we are trying to find the last little remaining portion there, which is TW. So I'd say, okay, how does my orange relate to the red, right? How do I relate the two things that I do have? Well, I know that this, our orange, is 1/3 of the whole thing. So we can do this a couple of ways. I know that if I triple my 5x minus 3, it's going to give me the 7x plus 3, the whole thing. Or alternatively, right, you could say, if I take 1/3 of the whole thing, we'll get a single small piece. Okay, personally, because 7 and 1/3 aren't going to simplify nicely, I would prefer the tripling method, right? Again, fractions aren't like the worst thing ever, they're just easy to make mistakes with. Okay, so let's distribute that 3. We get 15x minus 9 equals 7x plus 3. Subtract that 7x, both sides, and you're left with 15 minus 7, which gives us 8x. I'm also going to add that 9 to save a little work. So equals 12. And then we just need to finish it off there. So divide by 8 on both sides. And we get x equals, simplify your fraction. 4 is your common number. 4 goes into 12 3 times and into 8 twice, so 3/2. Now, keep in mind, your original goal was to find the length of TW. It wasn't to solve for x. X is what we needed to finish this, right? So let's go to our very last segment. So now we just say, okay, now I need to find that blue length only. So how do we do that? Well, think about it. If we had, let's go back to our orange piece. That one's the easiest to work with, right? How does our orange relate to the blue? Well, I know that if I have 2 of those orange pieces, the 5x minus 3s, right? If I have 2 of those, we get 1 of the blue, which is our TW. I don't know what that is, but I do know it equals the blue segment, right? So if we have 2 of the oranges, we get the blue, and we just happen to know what x is, right? Plug it in. So 5 times 3/2 is 15/2. Okay, so we have 2 times 15/2 minus 3 is the segment we're looking for. We just need to simplify this, right? Common denominator, I'm going to multiply top and bottom by 2 there, so we get 6/2. So 15 minus 6 is 9, so 9/2 times 2 equals our TW segment. Well, double 9/2, we get 18/2, which is just 9. And there's your length. Final answer, that's what you're looking for. Done. Okay, now the last but not least, it says find find x. Oh, apologies. If r to h is this last little segment down here, is x minus 7/2. And given that ht, this segment right here, is x minus 2 all over 2. And our goal is to solve for x. So I'd say, okay, well, right now, we don't have any kind of centroids, right? This double half relationship that we've been working with on these other ones doesn't really work. So we're not working with that centroid point. We're not even working inside the triangle. We're just looking along one of the lengths. We'd say, okay, well, assuming that all of the lines that were given here are all medians, right? Definition of a median, remember, is a line that starts at a vertex and goes to the, and this is going to be the most important part, midpoint on the opposite side. That tells us that point H right here is a midpoint. Why is that helpful? Well, that just happens to tell you that T to H and H to R are congruent, meaning that their lengths, the value of those lengths, if those are congruent segments, those lengths must be equal. Okay? Don't overthink these. Remember what you're working with. All right? And then we just need to solve. Now, first and foremost, what I like to do is I like to clear my fractions, right? Get those out of the way so it's harder to make mistakes. So on the left, we can undo that by multiplying 2, but what you do to one side, we do to the right. Remember, you're multiplying all of that side by 2. So on the left, we just get x minus 2. On the right, we get 2x minus 14/2, right? And 14/2 is just 7, right? Half of 14 is 7, okay? And now all of your fractions are gone. This is a little easier to work with here. So I'm going to add 7. And while I'm adding 7, I'm also subtracting x. So that moves everything onto different sides. So negative 2 plus 7 is 5, and 2 minus 1 is just 1. So x is 5. Double check your answer, make sure it works. 5 minus 2 is 3. Half of 3 is 1.5, right? 3 halves. It's a positive number. That works. Okay, 3 minus 7 halves. Well, if we plug that in, then I'd say, okay, well, 7 halves, if you remember, right, 3 goes into 7 3 times. Oh, wow. I just kind of struggled there for a bit, right? Sorry, 2 goes into 7 3 times, right? So technically what you're doing is you're looking at an, hold on, why am I saying 3? So awkward. Apologies, you're plugging in 5. Let me just write this out so I know what I'm doing. Minus 7 halves, right? 2 goes into 7 3 times, so 5 minus 3.5, because we have that 1 left over from the 1/2, right? When you plug it in, this is 1.5, positive length, it works. That was way harder. I made that way harder than it needed to be. But essentially, all of your solutions work. You plug them in, you get positive numbers back. Huzzah. Okay, and there you have it. Those are medians as well as mid-segments. Thanks for watching.